What is 54 as a Roman numeral? Here is a list of the Roman numerals and their equivalents. So we have I is equal to 1, V is equal to 5, L is equal to 50, C is equal to 100, D is equal to 500, and M is equal to 1000. The rules governing how Roman numerals are written are as follows. Numerals are written from left to right, beginning with the largest and ending with the smallest. The value of the number is determined by adding all of the numerals. When the rule is violated, in which case the smaller number will be placed first, the numeral is subtracted from the larger numeral that it precedes. All that it means is that Roman numerals are generally written from the large to the small. When the small comes before the large, the small is subtracted from the large. So let us see how some numerals are written before we attempt to write 54. 3 in Roman numerals is written as I. So all we have to do is add the values for I, 1 plus 1 plus 1, and that is equal to 3. 4 may be written as I. However, in expressing numbers by using Roman numerals, it is more appropriate to use a smaller number of symbols. We therefore place the smaller value, which is I, before the larger value, which is V. So we have 5 minus 1 is equal to 4. So instead of writing 4 I's, we are going to be using only 2 symbols. We are going to be using a V and an I. Typically, when we write Roman numerals, you will expect the V to be written before the I. However, when we reverse the order and we put the smaller one, which is the I, before the V, then we need to subtract the value of the I, which is 1, from the value of the V, which is 5, and we end up with 5 minus 1 is equal to 4. If we stick to our first rule by writing large to small from left to right, the number 54 may be written as, we know that X is what? X is 10, although it is not in this list. X is 10. So we have 10, 20, 30, 40, 50. And then 1, 2, 3, 4. So we have 54. It may also be written like this. L. L is 50. And we have 1, 2, 3, 4. So that is also 54. Or we may be a little bit harsh and write 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 1, 2, 3, 4. However, it is more appropriate to express the answer by using the smallest number of symbols possible. So 50 may be represented by a single symbol. So that is the symbol that represents 50, L. Of course, we need to account for the 4. 4 may be written as 5 minus 1. In this case, I is placed before V, resulting in a subtraction. So this one we have what? 50 is the largest. Then we should write V followed by I if we are just writing typically according to the rule. However, because we are violating the first rule by putting the small one before the large one, then we subtract the small from the large. So this is 1 to be subtracted from 5, so we have 4. The correct answer is option C. Mr. Brown spent 30% of his vacation fund on accommodations, 25% on traveling, and 10% on food. If his vacation fund is $500,000, which will give the amount of money that he spent. The format of the answers will give us an indication of the extent to which we are required to simplify our working. The amount of money spent as given in the statement of the problem is given as percentages. We will only consider the options that are given as percentages. So only options A and B are given as percentages, Jerry. Now, Jerry, how do we know that those are given as percentages? Good, because the fraction has 100 as their denominators. So we are sure that these are representative of percentages. The amount of money spent will be determined by the total percentage. We are highlighting the percentages in the statement of the problem, and the total amount spent, or the total percentage spent, will be the sum of those percentages. 30 plus 25 plus 10. And that is equal to 65%. Of our two possible answers, the one that makes use of 65% is option A. Our correct answer is therefore option A. Also, 65% means 65 out of 100, which may be represented by the fraction 65 hundredths or 65 over 100. This may then be multiplied by the vacation fund of 500,000. So we are just saying that this 65% means 65 out of 100, and we will multiply that fraction by the total amount of money allotted to the vacation fund, which is 500,000, and that will give us option A. What is 11% expressed as a decimal? 11% means 11 out of 100, or 11 divided by 100. Let us therefore divide 11 by 100. And this is the one that Jerry Lewis hates. He hates when I use long division. We will first attempt to divide 11 by 100. Because we cannot, we will place a 0 over the 1 digit in 11, followed by a point, and place a 0 to the right of 11, converting it to 110. We will then say 110 to be divided by 100, and that is 1. And then we'll do what? Place the 1 over the 1's digit in 110. Then we will proceed to say 1 multiplied by 100, and that will give us 100. 100 is therefore placed below the 110 that we have right there. Then we say 110 minus 100, and that gives 10. Next, we will continue appending a 0 to the end of 10, right there. So we continue by putting another 0 here, because we know that 100 cannot go into 10. So we place another 0 right there. 100 to be divided into 100, and that will be 1 time. Then we say 1 multiplied by 100, and that gives us 100. So we are going to subtract 100 this time. And what do we get? 0. And we are sure that our answer is 0.11. The answer is option C. What is 11 expressed as a decimal, we are going to take another approach. When dividing by 100, we desire to make the dividend smaller by 2 decimal places. Whenever a number is not accompanied by a decimal point, the position of the point is considered to be to the right of the number. In diminishing the value of 11 by 2 decimal places, the position of the point will be located 2 decimal places to the left relative to its initial position. So we are going to 1, 2. We may write a 0 in front of the point, and the correct answer, as we have discovered already, is option C. Which number has factors 2, 5, and 7? If a number x is a factor of another number y, this means that x can divide into y without leaving a remainder. We may say also that y is divisible by x. Therefore, 3 is a factor of 12y. Okay, that's correct, Jerry. What about 5 is a factor of 20? Alright, you will not get away this time, Jerry. 5 is a factor of 20, means that 5 can divide into 20 without leaving a remainder. What is 5 into 20, Jerry? Oh, Jerry is disappointed that I'm asking him such a simple division problem because he knows all his multiplication tables from 1 to 12. And yes, Jerry, and he's telling me that he knows some more multiplication tables that are greater than 12, and that is excellent. So, we know that 5 is a factor of 20 and 7 is a factor of 28. This is because 3 can divide into 12 without leaving a remainder, 5 can divide into 20 without leaving a remainder, and 7 can divide into 28 without leaving a remainder. And that is why those numbers are factors. So 3 is a factor of 12, 5 is a factor of 20, and 7 is a factor of 28. So let us first take an approach in which we make use of the knowledge that we have of the numbers. So we know that 10 is 2 times 5. Right, and we can see that 7 is not a factor of 10. So we know that option A is not correct. So we take a look at 35, and we know that what? 35 is 5 times 7. And look here, we have a 2, so we know that 2 is missing. So 2 is not in this one, so option B is not correct. 14 is 2 multiplied by 7. 2 multiplied by 7, and of course, we realize that the 5 is not included. We immediately see that 5 is not a factor of 14. So option C is not correct. By the process of elimination, namely options A, B, and C are not correct. As a matter of fact, the statement here says that options A, B, and C are all incorrect. The correct answer is therefore option D. So, we have other approaches that we can take. We are going to take another one. So, we will take another approach which all of the students, including Jerry Lewis, should be familiar with. Right, Jerry Lewis is saying that he's familiar with it, but he's not comfortable with it because it's too long. Alright. So then, we will find all the prime factors of the numbers in options A to D. So we will begin with option A, which of course is 10, and find the smallest prime factor that can divide into 10 without leaving a remainder. That number is 2. And 2 will divide into 10 5 times. We are all familiar with this little table, and we use it a lot when we are trying to discover the highest common factor or lowest common multiple of a set of numbers. So no problem working with this one. So when we have 5, what do? Find the smallest prime number that can divide into 5, and that is 5. 5 into 5 is 1. And when we have the quotient working down to 1, then we are sure that we have exhausted all of our factors. So the factors are 2 and 5. So with the system reduced to 1, we need not go any further. We see that the factors are 2 and 5. 7 is automatically out of option A, and of course option A is incorrect. So we move to option B with 35. So we find the smallest prime number that can go into 35 without leaving a remainder, and that is 5. 5 into 35, 7. And we find the one that can go into 7, that is the smallest prime number that can go into 7 without leaving a remainder, and that is 7. So we say 7 into 7 is equal to 1. And of course, we have completed because our quotient has worked down to 1. So we have exhausted all of our prime factors. So we see that the factors of 35 are 5 and 7. So option B is also incorrect because one of the factors is missing. So we are working with option C, and we are doing the same thing, using the smallest prime factor that can go into 14 without leaving a remainder. So 14 divided by 2 is 7. And we use the smallest prime factor that can divide into 7 without leaving a remainder, and that is 7 into 7, and that will give us 1. So we have exhausted that, and which one is missing? We have 2 and 7, 5 is missing. 5 is not a factor of 14. Option C is incorrect. Let us finish up with option D. The smallest prime number that can divide into 70 without leaving a remainder is 2. How do you know that 2 can go into 70 without leaving a remainder, Jerry? Okay, that is very good, Jerry. 70 is an even number, and all even numbers can be divided by 2. How do you know that it's an even number, Jerry? Okay, very nice. Jerry is saying that all even numbers end with either 0, 2, 4, 6, 8. So Jerry is well on top of his mathematics. He should get 100 in his GSAT. So 70 divided by 2 is 35. And the smallest prime number that can go into 35 without leaving a remainder is 5. So 5 into 35 is equal to 7. Okay, this is another one for you, Jerry. How, by looking at a number like 35, you are sure that 5 can go into it without leaving a remainder? That's another one for you, Jerry. Okay, that is very good. Jerry is saying that every whole number that ends with a 5 or a 0 is divisible by 5. That means 5 can go into any whole number that ends with a 0 or a 5 without leaving a remainder. So 35 ends with a 5. Therefore, 5 can go into 35 without leaving a remainder. So Jerry, if you do not get 100%, the exam is not fair. The smallest prime number that can divide into 7 without leaving a remainder is 7. 7 divided by 7 is equal to 1. And what do we know? We have exhausted this particular table. And there we have them, 2, 5, and 7. The list of factors 2, 5, and 7, as required by the statement of the problem, is present in option D. So that is our correct answer. The options had only prime factors, making the question simpler. If students are strong at their multiplication tables, they may not need to use the methods that we have discussed. the answer could have been figured out on inspection. And while I was reading the statement, Jerry was asking the question at the same time. Then why do we have to use them anyway if we can do them without? Because, Jerry, sometimes the problems are not so clear-cut and they are not so simple. They are not in such a simple term. And it is very important for you to learn certain mathematical methods in order that if the problem is harder or is some way different from the ones that we have, that you are sound and you have enough mathematical principles on which to solve them. You cannot just look at things one way, Jerry. What is 679 written in expanded form? Write down the number 679. There we have it. And then write down the place values. This is Jerry's favorite problems. Place values. Jerry loves place values. Place values, Jerry. Replace the word in each place value with the numerical forms. So, 9 is indicative of 9 ones and 7 tens and 6 hundreds. Okay. The answer may now be written in expanded form. So 6 times 100, 6 hundreds, and then what? 7 tens, and then 9 ones. Right. So the answer is option C. Very nice. Under examination conditions, students may look at the number and read it as 679 and immediately discover that the correct form should contain 6 multiplied by 100, 7 multiplied by 10, and 9 multiplied by 1 without going through a time-consuming process. And don't ask me, Jerry, because I've explained already why we need to go through processes in order to arrive at our answers. Half dozen mangoes cost $120. What will 10 mangoes cost? 1 dozen is equal to 12. So half of a dozen is equal to half of 12, which is 6. We may therefore rewrite the question: 6 mangoes cost 120. What will 10 mangoes cost? Let us use a simple argument to solve our problem. We have 6 mangoes equivalent to $120. We are required to take the cost of 6 mangoes and arrive at the cost of 10 mangoes. Our proposed solution will take us from the cost of 6 to the cost of 10, but we will go by way of the cost of 1. So we are going from 6 to 10, but we are going to use the cost of 1 mango to help us. So we have the cost of 6 mangoes. The cost of 1 mango will be less. We therefore divide $120 by 6 in order to get the cost of 1 mango. So let us do that. So the cost of 1 mango is $20. Now that we have the cost of 1 mango, our next step is to determine the cost of 10 mangoes. So 10 mangoes will definitely cost more than 1. We will therefore multiply the cost of 1 mango by 10. So 10 mangoes will be equivalent to the cost of 1 multiplied by 10. So 20 multiplied by 10, and our answer is $200. And the correct answer is therefore option B. We have the same problem, and we are going to solve that problem by using ratios. 2 ratios will be used. We will therefore need to develop a system of consistency. On the left side, we will have the number of mangoes, and on the right side, we have the cost. So, half a dozen mangoes cost $120. So the numbers 6 and 12 will go in the first ratio in their appropriate places. So there we have them. The number of mangoes is 6 and the cost is 120. So this is saying, what will 10 mangoes cost? So we need to determine the cost of 10 mangoes. We know the number of mangoes, but we do not know the cost. So let us call the unknown cost C. So there we go. The 10 for the number of mangoes go in that column, and the C for the cost goes right there. So let us write the two ratios as fractions and equate the fractions and solve the equation to determine the value of C. So let us write the ratios as fractions. The first number is the numerator and the second number is the denominator. Right? And the other one so let us cross multiply. So 6 times C is equal to 120 multiplied by 10, or 10 multiplied by 120. So we are saying 6 times C is 6C. So 6C is equal to 120. So find C by dividing 6 on the right hand side. So 6C means 6 multiplied by C. We are having a relationship of multiplication on the left hand side. So in order that the 6 may be transposed to the right hand side, we will have to do the opposite of multiplication, which is division. So we are going to divide by 6 on the right hand side. So C is equal to $200, and that is represented by option B. In which unit is yam measured? The quantities in which mass is measured are related to gram. So if it is mass, we are going to measure that in grams. When measuring yam, the mass is usually found. Therefore, the unit used to measure yam must be related to gram. Kilogram is the correct answer, and it is option A. Units like kilogram, decigram, milligram, etc. are all units to measure mass. However, the standard international unit is kilogram. What time is shown on the clock? Before solving the problem, let us clarify some conventions. The shorthand is the hour hand. While referring to it, the difference in time between a number and its nearest neighbor is 1 hour. So this is the hour hand, right? It is usually shorter than the minute hand, and it is usually bolder than the minute hand. So between 7 and 8, if this hand moves from 7 to 8, the period of time that would have elapsed would have been 1 hour. The long hand is the minute hand. While referring to it, the difference in time between a number and its nearest neighbor is 5 minutes. So if we are using or counting by using this hand, between 9 and 10 we have 5 minutes. So we would have 5, 10, 15, etc. The hour hand is between 8 and 9 o'clock. The time is therefore after 8, or we may say to 9 or before 9. In order to determine how long after 8, we will have to refer to the minute hand. At exactly 8 o'clock, the minute hand is on 12. And that is 0 minute after 8. So let us take a look at that again. In order to determine how long after 8, we will have to refer to the minute hand. So we know that is after 8 because this has gone past 8. So we know that is after 8. But we do not know how long after 8. In order to know how long after 8, we will have to refer to the minute hand. At exactly 8 o'clock, the minute hand is on 12. So at exactly 8 o'clock, this one will be pointing on 8 and the minute hand would be on 12. That is exactly 8 o'clock. That is no minute after 8. It is exactly 8 o'clock. Like that. We will count the number of minutes that we need to spend in order to get to the position of the minute hand. So we know that minute hand is right here. So we need to know how many minutes we need to count all the way from here, from 0 minute all the way around to where this is. How do we count the minutes? Remember that the difference between this and this is 5 minutes if we are counting by using the minute hand. So 5 minutes each time for each digit. So let's go. 5, 10, 15, 20, 25, 30, 35, 40, 45. So I was counting too slowly, right? So I get caught, just like Jerry, by a counting problem. Usually Jerry has a counting problem, and now I'm showing myself to have that problem also. So let's go again. 5, 10, 15, 20, 25, 30, 35, 40, 45. So in order that the minute hand will go all the way there, we are sure that 45 minutes would have elapsed. So it would be 45 minutes after 8, and that would have been explained to be 8:45. The 45 minutes is after 8. The correct time is therefore 8:45, and the correct answer is option B. What time is shown on the clock? That is the same problem. As we said before, when the hour hand is between 2 hours, we may say that the time is after one of the indicated hour or before the other one. The format of the answers indicate that after or past the hour is required. So because of this format, we know that these are saying that like 5 minutes after 8, 45 minutes after 8, 15 after 8, 15 after 9. So we are saying that all of this is saying after because of the format that the answers are given. Usually, when the time is between 2 hours, the half of the clock in which the minute hand is located tell us whether to or after the hour is appropriate. If the minute hand is in the first half going from 12 to 6, then after or past the hour is more appropriate. So that half is past or after. So that is the side of the clock in which if the minute hand is located, we say that it is after the hour. If the minute hand is in the second half going from 6 to 12, then to or before is appropriate. So that is to or before the hour. So we have the minute hand is over here. We typically say past the hour or after the hour. If the minute hand is over here, we say to or before the hour. We have shown how we may determine the number of minutes after a particular hour by counting the minutes in a clockwise direction. Because the minute hand is on the to or before side, we may say that the time is such and such a number of minutes to 9. In this event, we count the number of minutes in a counterclockwise or anti-clockwise direction. So the minute hand is on this side, which is the to side. Therefore, we are going to say the time is a particular number of minutes, not after 8, but to 9, because we are in this region of the clock. So we are, instead of saying after 8, we say to 9. Now, it is not wrong to say after 8, but it is typical of people to say it is 5 minutes after 8 or 10 minutes to 9. We will begin our counting at 12 because we are counting minutes 2, which is the position of 0 minute. So we are right there. The number of minutes before 9 may be determined. Right. So we start right there and we are going in this direction to get to 9. That is for the minutes. So we have 5, 10, 15. So the time may therefore be read as 15 minutes to 9 or 15 minutes before 9. A period of 15 minutes is a quarter of an hour, and those periods may be indicated on the to or past side. So if we have our hand right here, because it is a quarter of an hour, we know that that is a quarter to 9. And here we have also a quarter after or a quarter past. Generally we say quarter past. When the minute hand is pointing to 3, we say that it is a quarter past the hour. And when it is pointing on 9, we say that it's a quarter to the hour. The time indicated is therefore quarter to 9. The 6th hour is halfway around the clock. When the minute hand is on 6, the time is half past the hour. Although it is also half to the other hour, we never use half in that way. So we never say half to 10 or half before 11. We generally say half past 9 or half past whatever hour it is half past. Now, the clock shows the time that a man arrived at work. He is 15 minutes late. At what time should he arrive? If the man is 15 minutes late, then the answer that we are looking for should be 15 minutes earlier than 8:45. We therefore need to go to a time that has already passed. So, if the man should have been there earlier, we need to go to a time that is 15 minutes earlier. We therefore need to go to a time that has already passed. We will begin our counting at the present position of the minute hand and consider it to be our 0 minute. So we are going to count 15 minutes. So we are going to go to the present position of the minute hand and say that is 0. And we are going to count 15. So we need 15 minutes earlier. See what happens. We will count 15 minutes in a reverse direction. That is how we determine a time earlier. We go back in time, right? We go back in time. So in a reverse direction, in order to determine where the minute hand would have been 15 minutes ago. So we'll count 15 minutes in a reverse direction in order to determine where the minute hand would have been 15 minutes ago. So let's go again, Jerry. 5, 10, 15. So 15 minutes ago, that is the position where the minute hand would have been. So the hand would have been pointing to 6, indicating 8:30 or half past 8. The correct answer is option B. We could have progressed by subtracting 15 minutes from 8:45. So that's another option, subtracting 15 minutes from 8:45. And if we subtract that, we'll have what? 5 from 5, 0. 1 from 4 is 3. 0 from 8 is 8. And we have 8:45, and we would have received the same answer as the one that we have received by reversing the clock by 15 minutes. The perimeter of a regular decagon is 88 centimeters. What is the length of each side? A decagon has how many sides? 10 sides. Because the one in question is regular, the sides are all equal in length. So that is a regular decagon. All sides are equal in length. And it has 10 sides. Its perimeter is a measurement around it and may be found by adding all of its sides. So the perimeter is equal to 88 centimeters. The perimeter is given and we need to find the length of each side. The length of one side must be smaller than the entire perimeter. We therefore divide the perimeter by the number of sides, 10. Of course, the number of sides is 10, so we need to divide the perimeter by 10 in order to find the length of one side. So the answer is option C. 88 divided by 10 is equal to 8.8, and of course 8.8 centimeters is our answer. The key word in the statement of the problem is each. Problems that have that word tend to require division. Let us use the next slide to divide 88 by 10. This is what you don't like, Jerry, but it's not what you like. We will begin by saying 10 into 88, and that's 8 times. Then we say 8 multiplied by 10 is 80, and we are going to subtract that 80 from 88. And what do we get? 8. Then we say 10 into 8, and that's not possible. So we place a point after the 8 in the quotient, that is, and append a 0 to the 80. And then what do we say? 10 into 80, or 80 divided by 10, and that is equal to 8. And then we say 8 tens, 80. Right. And, of course, subtract 80 from 80, and the result is 0. So our division is finished, and we have 8.8. That is our answer. The answer is 8.8. When dividing by 10, we decrease the value of the dividend by 1 decimal place. It does not contain a visible decimal point, so we consider the decimal point to be at the extreme right. In diminishing the value of 88 by 1 decimal place, the position of the point will be located 1 decimal place to the left relative to its initial position. Just 1 decimal place, Jerry. That won't take too long. This also confirms that the answer is 8.8, which shows how to find the area of this shape. The shape on the right is a square. To find its area, we may use the fact that a square is a rectangle in which the length and width are equal. The other dimension is also equal to n, so the length and the width are equal, so we are sure that this is also n. To find the area of the rectangle, we multiply its length by its width. So area is equal to length multiplied by width, but in this particular case, the length is n and the width is n. As indicated in the diagram, both length and width are equal to n. So A is equal to n by n, or n multiplied by n. The correct answer is therefore option D. If a clock shows 7:25 a.m. now, what will it show 45 minutes later? We need to tell the time that will be indicated by the clock 45 minutes from now or later than now. We may do this by advancing the minute hand by 45 minutes. So, let us begin at the present location of the minute hand and call that position 0 minute. So this is the present position of the minute hand, and we are going to call that 0 minute so that we can count 45 minutes in advancing the clock. From that position, let us count 45 minutes. 5, 10, 15, 20, 25, 30, 35, 40, 45. That's it, 45 minutes. That will be the new location of the minute hand. So the minute hand will go right there. The minute hand would have passed 12. This means that the hour hand will have passed another digit. So because the minute hand passed 12, the hour hand will need to go beyond another digit. So let us do that. We move it past 8. The hour hand would have passed 8 and the minute hand would have been on 2. This means that the present time is 2 periods of 5 minutes after 8. The correct time is 8:10 or 10 minutes after 8. This is where the minute hand is at its 0 position. So it would have been 5 past, then 10 past. The correct answer is option C. Of course, we can take another approach in which we add the period of 45 minutes to the instant in time of 7:25. And of course, we will put a 0 here as a placeholder. Adding the minutes, we get 25 plus 45 is equal to 70. This is more than 60 minutes. So because this is more than 60, we are going to convert this to hour and some minutes. So 70 divided by 60 is 1, and the remainder is 10. So write down the 10 and carry 1 to the hour column. In the hours column, 7 plus 1 is equal to 8. The time sought for in the statement of the problem is 8:10 or 10 minutes past 8. Now we are just going to show how by dividing 60 into 70 we get 1 and remainder 10. So let us see how that is done. 70 divided by 60 is 1. So what do? The 1 goes there, and we say 1 multiplied by 60 is 60, right? 1 multiplied by 60 is 60, and 60 goes there. Then what do? We subtract 60 from 70, and the result is 10. So we have 1 hour, and the remainder is 10, so that's 10 minutes. Which is the same as 1 kilometer. Notice that all of the answers contain meters. The statement of the problem requires the number of meters to be identical to 1 kilometer. How many meters make a kilometer, Jerry? Okay, Jerry said that fast. He was very quick on that one. 1,000 meters make a kilometer. So let us show a table with the prefixes that are used in measuring distances and their meanings. So there we have, in measuring distance, kilo means 1,000 times, hecto 100 times, deca 10 times, deci 1/10, centi 100th of, and milli 1,000th of. But we are interested in kilo. That means 1,000 times. So we are looking for the answer that will be 1,000 meters. So let us look at the slot with kilometer. Kilometer, 1,000 meters, right? Kilo means 1,000 times, so we need to determine which will add to give 1,000. Which one of these will add to give 1,000? The numbers in option A and D are automatically out because what? This will not add to give 1,000. You can see that immediately. And of course, D, we have 1,000 and 1,000. That's not going to add to give 1,000. So we know that those are automatically out. Now, we know that we're just going to be using our knowledge of digits, not just to add them. So we say that we don't have to add these, just use our knowledge of digits. We know that 600 plus 400 is equal to 1,000. So one of the numbers in B, look at option B, one of the numbers is greater than 600, greater than the 600, and the other one is greater than 400. So we are sure that this one is going to be too many. So we have what? 650 plus 450, that's not going to work. 600 plus 400 is equal to 1000. This is more than 600. This is more than 400. That will not give the correct answer. Their sum must be 1000. The correct answer is option C. So this one is too small. This one is obviously too large. This one will add to give a figure that is more than 1000. So we are sure that that one is our correct answer. Creationists claim that the earth was created 6,000 years ago. How many centuries does this represent? Of course, Jerry, we need to know the number of years in a century, and that is equal to 100. A century is equal to 100 years. We need to determine how many periods of 100 years is in 6,000 years. This may be achieved by dividing 6,000 by 100. When dividing by 100, we desire to make the dividend smaller by 2 decimal places. Whenever a number is not accompanied by a decimal point, the position of the point is considered to be to the right of the number. Jerry prefers to use the relative position of the points and the digits in dividing by 100, 10, and 1000 rather than using long division. So then, when I have another problem that involves long division, I'm going to ask Jerry to do it. Jerry is always overjoyed when I'm solving a problem that divides by a power of 10. He is very, very happy to see that I'm using a method like this. He does not want me to use any other method. So, when I'm working with another method, I'll cause him to work that one out. So whenever a number is not accompanied by a decimal point, the position of the point is considered to be to the right of the number. In diminishing the value of 6,000 by 2 decimal places, the position of the point will be located 2 decimal places to the left relative to its initial position. The trailing zeros may be discarded in the final answer. So the trailing zeros, we can do without them. The correct answer is therefore option C. Which is the same as 1 centimeter squared. In answering the question, I will make reference to a question that one of my students asked me. In answering this question, I will make reference to a question that one of my students asked me. Why is area measured in centimeters squared? I explained to him that the unit of area is derived from finding the area of the most basic shape. And the most basic shape is a square. So this is usually a square. 1 unit long by 1 unit wide. Like that, 1 centimeter by 1 centimeter. To find the area of the rectangle, which is of course a square, because a square is a rectangle with the length and the width equal. We multiply its length by its width. So area is equal to length by width. So we're going to substitute the length. What is the length? 1 centimeter. And of course, the width is also 1 centimeter. So when multiplying, what do? We say 1 multiplied by 1 is 1. And centimeter multiplied by centimeter is centimeter squared. Whenever we multiply anything by itself, it is the same as squaring it. This applies also to centimeters. If we are multiplying centimeters 2 times, then we have centimeters raised to the power of 2. Therefore, 1 centimeter squared is equal to 1 centimeter multiplied by 1 centimeter, and the correct answer is option D. How much water is in the container? There are 4 marks that indicate volume, and there are 4 marks that indicate volume on the diagram. The final mark is at the 4-liter mark. This means that each mark is represented by 1 liter. So we have 1, 2, 3, 4 marks. And we have 4 liters. Therefore, each mark is representing 1 liter. So let us first indicate the level of the water in the container. That's right there. The position of the arrow is at the 3rd marker from the base of the container. With each marker representing 1 liter, the volume of water in the container is therefore 3 liters. We may also make use of the fact that the level of the water is halfway between the 2 liters mark and the 4 liters mark. The number that is halfway between 2 and 4 is 3. There are therefore 3 liters of water in the container. The answer is option B. So we may say that we have 4 marks representing, of course, 4 liters. Therefore, the 3rd mark would be the 3 liters mark. Or we may say that this mark is exactly between 2 liters and 4 liters, making it 3 liters. Which is measured by finding its mass? Option A. Juice is liquid. Therefore, we use the unit that is used to measure liquid in order to measure juice. Liquid measures are in liter and other related units. Option B. Rice. Rice is generally measured in kilogram. Kilogram is a unit of mass. This option is correct. What about option C? Cloth is measured by using a meter rule. Or they say a yardstick. The units of length, not mass, are therefore used to measure cloth. Option D. Apart from the fact that we have already found the correct answer, the temperature of a medium tells us how hot or cold it is and has nothing to do with mass. Option D is also incorrect. Which line shows a chord to the circle? A chord is a line that is drawn between 2 points on the circumference of the circle. So it has to go from a point on the circumference to another point on the circumference for it to be a chord. In the list of lines that we have in the options, because we have a lot of chords there, but in the list that we have in the option, only AB meets the requirement of a chord. It can be shown to have endpoints that are on the circumference of the circle. So there we have them, AB on the circumference of the circle. So we have A on the circumference and B on the circumference. Therefore, AB is a chord. All of the other lines in the options have one endpoint each that is located on some other point than the circumference of the circle, namely the center of the circle. They are not chords. And we're going to show the others. We have OB, OC, and DO. Notice that each one has a point at the center. Each one has a point at the center. So we are sure that those do not represent chords. They represent radii. The distance between two cities on a map is 3 centimeters. If 1 centimeter on the map represents 50 kilometers, what is the actual distance between the two cities? The problem may be solved by using ratio. To be consistent, the distance on the map will be placed on the left-hand side of the ratio, and actual distance will be placed on the right. So, the fact that 1 centimeter on the map is equal to 50 kilometers will be considered first, and the value will take their appropriate places like that. So we have the distance on the map and the actual distance coming after. So the distance between two cities on the map is equal to 3 centimeters. We need to determine the actual distance between the cities. So let us call that unknown or actual distance x. The simple argument may be used to solve the problem. If 1 centimeter represents 50 kilometers, then 3 centimeters must represent 3 times the amount that is represented by 1 centimeter. Okay, we have it right here. 1 centimeter on the map represents 50 kilometers. 1 centimeter on the map represents 50 kilometers. Therefore, if 1 centimeter represents 50 kilometers, then 3 centimeters will represent 3 times 50. The answer is 3 multiplied by 50. However, because the multiplication is commutative, 3 multiplied by 50 is equal to 50 multiplied by 3. The correct answer is option A. What is the volume of a cuboid shown? The volume of a cuboid is given by volume is equal to length multiplied by width multiplied by height. Volume is therefore equal to the length, which is 6 centimeters, multiplied by the width, which is 5 centimeters, multiplied by the height, which is 4 centimeters. And that is what we have right here. Volume is equal to 120 centimeters cubed. As the numbers are being multiplied, so are the units. And of course, each unit is a centimeter. There are 3 occurrences of centimeter in the product. When we multiply a number or algebraic term by itself 3 times, as we have it right here, the result is the cube of the number or the term. The unit is therefore centimeters cubed, or centimeters to the power of 3, but we generally say, when we are referring to units, centimeters cubed. The correct answer is represented by option D.